Okay, and now we come to this point where we talk about sigma notation. Now that's what you just saw me type in the calculator. This is called sigma notation. This finds partial sums. So this finds partial sums when we add up a certain number of sequences. Now in the calculator you don't have to start from the first term. This says start from the first, but if we wanted to find the partial sums of terms 3 through 7, you could just start at 3 and end at 7. And so that's all that we use. So here it's just asking us to find a couple particular values. So let's go to our calculators and we're going to find these values. So first we'll say, I'm going to just clear all this out of here. We want to find partial sum. So I'll go here to the button next to 9. That's where partial sum is from when n is the value of 1 and it goes up to, I believe it was 4. And the partial sum we want to find is n squared minus n. N squared minus n. And that would give us the value of 20. Part B asked us to find from the partial sums of 2 through 5th terms of 3n plus 3 over n. So this time we'll do it again. From n being the second term, we're going to add that all the way up till we get to the 5th term. And the equation was 3n minus 3, I believe, plus 3 all over n. In this case, we get the value of 317 over 20. You can press Control Enter to get it as a decimal, and there we see all of our values given there. So I'm going to take this back over here, and we'll put our answers. And so now we know that this one, again, you could write it if you wanted to, like that. That's the 4th partial sum, is 20. Now this one we would write differently just because it's not from the 1st to the 5th. But this we would say our value is 15.85. That would be our answer there on this one. So let's try it one more time. Now what do we do if we have to find the partial sum of infinity? So we can go to our calculators and we can try this. And so we do n partial sum. We want to go from n being 1 up to infinity. Now the calculator does have an infinite button. It's over here. Or no, wait, is it with the pi symbol? Yeah, it's with the pi symbol. You'll see infinity there. And we can type in the equation. It was 3 times something. What was it? 3 times 1 over 10 to the power of n. When you press enter, though, we have a problem. You'll see that our calculator does not know how to solve this. So since it doesn't know how to solve it, we got to figure something else out. And what I do, instead of typing infinity, what I will do is I backspace it and I'll type in something like 100 and see if a large number, because that just means n is going to go up forever and forever. Just pick a large number like 100. If it works, great. And so this is saying it's approaching 1/3 is what this is approaching. So this whole sequence, when you add them together, it looks like it's approaching 1/3. We can try it again. What did I just do there? I have not seen that before. Okay, let's try it again. And this time, what I will do is instead of putting 100, I want to go up here, and I'll try it at 1,000 and see if it'll calculate. Sometimes it gets too big for the calculator. I'm sorry, it's struggling with the calculator right now. Okay, let's change it to 1,000. And see, the calculator won't do that. It's too high for it. But we can try a different number that's still bigger than 100, that maybe is not exactly 1,000. So let's try, instead of 100, let's try 200. So, or instead of 1,000, we'll try 200. And it looks like it's still approaching 1/3. So that would be the value that we're going to say, is that this is approaching, here is 1/3, or if we wanted it as a decimal, 0.333 of that 3 repeating. So you just say 0.3 repeating like that. So whichever way you want to have it, I'll do the 1/3 because that's the most exact answer. That's what it's approaching. So now you can go ahead and try this one.